The next thing I want to talk about in this section is something called the tabular method. Now, the tabular method is a shortcut that we can use for integration by parts, but you can only use it if one part of the integrand can be derived down to 0, which means that you can take the derivative of that thing down to 0. Basically, we're going to be using it when our u is equal to something that's algebraic, whose derivative can eventually equal 0. And the other part has to be something that's easily integrated. So your dv has to be something you can easily integrate. It's really useful for powers of x multiplied by sine, or powers of x times cosine, or powers of x times e to the x. So let's look at number 7, where we're finding the indefinite integral, and we're going to use the tabular method for this. We're looking at this problem. It's not basic form. It's not a u-sub. I know I need to use liate because the only other thing I know how to do right now is integration by parts. I don't have a log. I don't have inverse trig. I do have algebra. So your u here would be x squared. Well, can you take this derivative down to 0? Yes. Since you can take that derivative down to 0, we're going to use the tabular method. Again, since we can take the derivative of x squared and eventually we're going to get to 0, we're going to use the tabular method. How do I do the tabular method? Well, you make a t-chart, and on one side you write u, and on the other side you write dv. So you grab whatever u is going to be, in this case x squared, and you start taking its derivative until you end up with 0. X squared, take its derivative, 2x. Take the derivative again, 2. Take the derivative again, 0. Once you get to 0, then you're going to assign signs, positive or negative, to these terms. And we always alternate positive, negative, positive, and then when 0 we stop because 0 is neither positive or negative. Then we write the other term in the dv location. You don't need to write the dx part. And then you integrate that term until you get to the same row as 0. The integral of the sine is negative cosine. The integral of the negative cosine is negative sine. The integral of the negative sine is positive cosine, and then you stop because you got to the row with the 0. Now for the answer is always going to be the product of this diagonal. So whatever u times the diagonal down of dv is, and then the next u times its diagonal down on dv, and then the next u times its diagonal down on dv. So you're just going to take that product until you reach the end of your rows. In this case, this is going to be x squared times negative cosine of x plus a negative 2x times a negative sine of x plus a positive 2 times cosine of x. And since I'm out of terms, go ahead and write your constant of integration. Again, x squared times a negative cosine plus a negative 2x times a negative sine plus a positive 2 times a positive cosine. Ran out of terms, write in your constant of integration. Finally, clean this up and you have negative x squared cosine of x minus and minus become a plus 2x sine of x plus 2 cosine of x plus c. We're going to do example 2 again, but we're going to do example 2 with the tabular method now. Just like we did when we talked about example 2 earlier, we have to rewrite this as a product. So it's still going to be the indefinite integral of 5x e to the negative 2x dx. That part won't change. But then we make our t-chart here. We have u and we have dv. Well, you remember is the algebra piece, 5x, and you can take the derivative of 5x down to 0, so start taking its derivative. 5x, the derivative of 5x is 5, the derivative of 5 is 0. Then put in your signs. Remember, they always alternate, positive, negative, all the way down. When you get to 0, you stop because 0 is neither positive nor negative. Then you write the other part as your dv. E to the negative 2x. Then you start integrating. Well, the integral of e to the negative 2x is going to be negative 1/2 e to the negative 2x, because remember, this guy here is linear. So we multiply the antiderivative by the reciprocal of the coefficient of x. And then we integrate again. Well, this guy here would be a negative 1/2 times a negative 1/2, or a positive 1/4 e to the negative 2x. And then we're going to just multiply this and multiply this. So in the end, this is going to equal that 5x times a negative 1/2 e to the negative 2x plus negative 5 times 1/4 e to the negative 2x. You round out of terms, you write your constant of integration. Clean that up. Negative 5x over 2 e to the negative 2x minus 5 over 4 e to the negative 2x plus c. And you'll notice this is the exact same answer we ended up with when we did example 2. What about example 8? It's not basic form. Technically, we could do a change of variable on this problem, but we're going to use the integration by parts tabular method because if we choose our u to equal x, we can take the derivative of that down to 0. And then this guy right here, this x plus 5 to the 4th, is easy to integrate. So let's make that table. If u is equal to x, the derivative of x is 1. The derivative of 1 is 0. We stop. And then what we need to do is put in our signs. So remember, we alternate between positive and negative. Once we get to 0, we stop. For our dv, we have x plus 5 to the 4th. Remember, this guy inside of here is linear, so this is really just like a w to the 4th. And we know how that integrates. That's going to be w to the 5th over 5. The coefficient of x is 1, and the reciprocal of 1 is 1, so I'd be multiplying that by 1. We know that this is just going to be, I'm going to write it as 1/5. 1/5 times x plus 5 to the 5th. I integrate again, so it's going to be an x plus 5 to the 6th, and I'm dividing by 6, so that makes that 1/30. In the end, this is going to equal this guy, and then this guy. So we have x times 1 over 5, x plus 5 to the 5th, plus negative 1 times 1 over 30, x plus 5 to the 6th. Ran out of terms, so I write my plus c. In the end here, this is just x over 5 times x plus 5 to the 5th minus 1 over 30 times x plus 5 to the 6th plus c.